like to introduce our first speaker for the day, who is Piyush Verma, who will be speaking on Do More with Your Matrix. Not only that, he is the CTO and the co-founder for Last9.io. Please welcome Piyush Verma.
Settled, everybody? Yeah. दरवाजे बंद कर दो. Cool. Cool, let's start. I'll start straight with the story. Once upon a time, there was an API server built by a developer called Bubbly. How many of you write code here? How many of you do not write code? That's okay, raise your hand. That's okay, cool, great. How many of you want to write code who don't write code? Explains. The API was a pretty simple API. It used to serve requests. This is a standard architecture. I guess most of you will associate with it. There are users, there's a load balancer. Load balancer is going to send data to some pods, which will speak with an RDS. The simplest, most configuration that we can imagine. Arey, baith jao, baith jao. Yeah. Okay. Like this way? Am I still audible? Okay, cool, great, yeah. API matured, so did Bubbly. API started serving more requests with time. Bubbly started seeing complaints bubbling from users. She started looking for problems, where they may exist in the code. With more power comes more observability. Well, you have more data, you have to observe more data. How many of you know what observability is? Like, have heard the term? Everybody? I'm vestigial, no now, I'll go back home. So anyway, Bubbly decided to instrument the Golang application to emit red metrics. We have heard this word, red, a lot. What does red mean? Rate, errors, duration. Pretty standard terms, right? Okay, cool, let's move forward. Every once in a while, requests would still get slow. Consumers will still complain. Oh, it's too slow, Maja is not happening, all that. Cool. Could it be the API? Well, no. Well, because we had the red metrics, so we know it's not the API anymore. But could it be the DB now? Or could it be the host CPU which is failing on Bubbly? We don't know. Nor does she. Bubbly realized that red wasn't enough. She started reading the Google SRE book. How many of you have read the Google SRE book? Okay, rest of you, please do not. Waste of time. So, well, it's just a big book. It doesn't tell you anything. Anyway, so the SRE book prescribes 4 golden signals: latency, error, traffic, and there's a new one, saturation. So, how many of you understand Hindi here? A lot of you. Saturation doesn't mean bhare baithe hain. It just means CPU bhar gaya hai, right? So, can I have my slides on this and instead of the video? Is that possible? Okay, regardless. So, yeah, next. So, saturation. So, Bubbly starts wondering about what saturation is. Again, the same thing? Okay. I can just get a hand mic and be done with this, no? Yeah, cool. Can I just get rid of this now? Okay, cool. Am I still audible? Okay, great. Yeah, that's much better. Yeah. Bubbly started wondering what saturation is. So she installed cube state metric to emit load metric from the pod. Pretty simple and easy. But what about the database load? What about the disk pressure? The problem could be either of the two places. Now, Bubbly installs CloudWatch-exporter because, well, the stuff was running on AWS to emit AWS RDS metrics. Pretty standard stuff. I guess everybody has done this. There's cube state metrics, you have CloudWatch exporters, everything, right? But hang on a minute. Didn't we start with Bubbly not being able to monitor one binary? And our solution is now 3 binaries. If one binary cannot run stably, how will 3 binaries run stably? I mean, it's not that you spread the problem and it goes away, right? And now there are 3 places to debug. There's one CloudWatch console, there's your red metrics console, and there's cube state also. We are really compounding the problem. Also, Bubbly also was emitting data to a hosted service. Well, because data has to be sent somewhere. And suddenly, she sees this one day. a payment method. The third one is a kidney, by the way. So, but that's what it costs, right? To send that much amount of data. Cool. Anyway, Bubbly decides to run a local copy of Victoria metrics. I just want to write that in the slides. So, but hang on a minute again. Didn't we say that she had trouble running one database, and now we're saying she has two databases to run? That doesn't solve the problem. It only compounds it further. Let's go further. Let's not think as a product owner. Let's think as a product guy, not as an engineer, because this is a typical mistake that we do. What we believe is, if we have more data, we have more observability. Does that really work that way? Like if I emit all the logs, will I become more reliable? Not usually possible. Let's see what the fundamental flaw here is. Why do we write reliable software? Okay, do you guys ever use Paytm, Swiggy, etc., and the error doesn't go through? I mean, the request doesn't go through. There's an error on your face. There is something which will not make it. You will have to retry, etc. Do you get irritated in that moment? Yeah, damn it. I just wish I could order that laddu right now, but I could not. Yeah. Anyway, the reason why you write good software is because you want your customers happy. Happiness is not measured by a reduction in errors. Just because I'm seeing the graph of errors reducing, does it mean that my customers are happy? Actually, it doesn't mean that. The one big indicator which ensures that your customers are happy is usually a metric which is hidden in the activity, in the session, so in increased user. Think about it. Your service is bad. You're returning a lot of errors, but day on day, your users keep returning. Would you really want to fix those errors? Not really. Why? I mean, they're coming back, right? How do you care? Or take the other way around, right? You're almost serving 99.9%, all the nines that we've heard, like 99.99999. But your daily user graph is dropping. What worth is that 9? Nothing. Because you can't retain your customers. You cannot. So the simple most metric that has to be measured is how do you retain your user? Because that is what reliability is about. And that's the metric that we actually ignore. But hang on a minute. With all of these metrics that we emit, more often that we realize that this important most metric is actually hidden in a database somewhere. Well, some of you will use Mixpanel for this or a segment for this, but none of our observability tools ever talk about that. They all talk about nines. But wait, what about the customer? What about the happiness there? What about the satisfaction? We don't speak about that. Introducing observability as code. And this is very important because we have started declaring. I'm hearing a voice. Somebody speaking in the talk. Yeah, okay. Is it from my phone is ringing or something? Okay, cool. So, oh, okay. My alter ego has a female voice? So, oh, bubbly. I get it. Yeah. Cool. So when we write software, right, we're declaring our infrastructure. You guys have used Terraform? Who has not? Okay, cool. So when you write Terraform, you're basically declaring infrastructure. Infrastructure is code, solved problem, very old problem. Deployments, how many of you write YAMLs? How many of you proudly write YAMLs? So, you proudly write YAML? Okay, so surprised? Cool. But observability is still left as a dashboarding activity. You emit your data, you will hunt through a metrics, there'll be a plethora of metrics, millions and trillions and so many. I mean, and half of them are not being used. Forget half of them, 90% are not being used. A fun statistic. But what if there was a way to declare this as well? While you write code, I clearly know it's my code. I know how it's going to come out as. I know what metrics I care for. But why can't I just declare it up front? Why do I really have to go through this process of installing binaries and YAMLs, etc.? Wish there was an easy way. Here's an easy way. You guys can read HCL, HashiCorp configuration language, but can you read this right now, or is it too small a font? Too small a font? Okay, then trust it works. Cool, ignore. So it's some pretty piece of code. Well, anyway, talks cannot cover code, right? So the crux here is, what we're doing is, we're writing a scraper. And the first metric that I'm emitting is daily active users. which is being pulled from a Postgres database of mine. There's a small query in there. And there's throughput, there is errors, standard metrics that we emit. To the same scraper, we're going to add more. Daily active user, which is a Postgres. It's a standard SQL query. And down below, there is another query, which is CPU load average. These are the 4 signals that we spoke about, right? If you look back, there's throughput, there is error, there is daily active user, and there is saturation. I didn't need anything else for so far in my debugging. If I needed more, I will add more. But if I could just commit this file and say, when I launch, this is all that I care for. Because rest, anything else, I don't care. If I need it, I'll add it. It's fine. This simple ability to declare the observability that you depend on when you go into production is what openmetrics-exporter is, a project that we built at last night and solves. Now let's go dissect this further. What are the advantages of doing it this way? I no longer have multiple binaries. I got just one single binary that I can just deploy. Either it works or it doesn't work. It's very simple. You know, how do you know it's not working? Well, I don't see any metrics. Pretty straightforward. Optimize metrics. Okay, you guys have used Prometheus with Golang. How many of you have? Raise your hand. Keep raising your hand if you have ever put an alert on go_threads or go_gc_runtime_delay. And there are 98 more such metrics which you have never used. Then why are you emitting them? Why are you filling up your database if you ever don't alert it on that? Has anybody ever alerted on go_threads? Tell me, one guy. I haven't. Anyway, cool. Correlation. The only way of correlating was plot it on a dashboard tool, use a mouse with a crosshair and see does it align. It reminds me of those days, you know, when, how many of you had a black and white TV in your life? Remember as kids, aaya, nahi aaya, aaya, nahi aaya. You know, we used to have that at the antenna days, right? It's exactly that way. Manually hunting through this dashboard, finding a crosshair, asking people to go through these large files. Metrics are correlated. They are in one single file. They all come aligned with one single timestamp. Why not use them together? And more importantly, it improves your productivity. It improves your productivity the same way as infrastructure-as-code did. This allows you to have this declarative control over it. And lastly, everybody speaks of build a bedrock of operational intelligence, but we just don't practice it. You know, we have our data everywhere. This allows you to put it in one single place. A typical flow in your life would look like this. You have the file, you commit it, the openmetrics binary will run it. It's compatible with all Prometheus scrapers. So it basically starts emitting data in openmetrics format. So any Prometheus agent or VM agent is able to scrape that. Let's start from the beginning again. Step 1, declare. Just like you would do in Terraform. Step 2, plan it. See what the output is going to look like. Step 3, just dispatch it. And once it's dispatched, you can start seeing the metrics in /metrics page, just like you would see on any other Prometheus compatible binary. You can see the data. One of the biggest thing here is faster feedback loop. What it does is, while you are writing these observability files, these declarative files, you can simply run them. What is your favorite visualization tool out there? Grafana? Anybody uses anything else other than Grafana? Okay, cool. There you go, Grafana. So just export it. Once you export it, you would actually see it in Grafana. So you know what the output is going to look like for you. Fairly straightforward. It's compatible with a bunch of sources. You can basically write these HCL files which can read data from Prometheus, from Stackdriver, from CloudWatch. Say a name and it's almost there. Well, you can also add more if you like. Reusability. One of the reasons why we actually, what are the key fundamentals of writing good software? Have we heard this thing called modularity, reusability, etc.? So we're built on top of that. So once you have written a module, a scraper, you don't have to write it ever again. You can simply publish it as a module and reuse it in all your other declarative pipelines as well. What this does is, let's say if I'm writing a project, right? And I have given a way of declaring my load balancer or my database or my daily active user in one environment. I can simply copy the module, refer to it, and reuse it in other projects of mine. So I don't have to keep copying code again and again. But why HCL and why not YAML? A lot of people ask us that. Why do you write this project in HCL and why not YAML? Here's a simple answer. YAML provides you job security. HCL lets you concentrate on the things. Let me give you a practical example of this. Can you do a 2 plus 2 in YAML? You cannot. But can you do it in HCL? Sure you can. The fact that you can write these smaller inbuilt functions straight embedded into the HCL makes your life a lot more easier. And this is fundamentally one of the reasons why HashiCorp tools are actually built around HCL, because it allows you like a mini programming framework right in there, right in your configuration files. So your configuration files are no longer just dumb copy-paste text blobs. They are literally have some kind of logic in it as well, because many a times you'll realize that, oh, I wanted to strip a name, I wanted to suffix pad something here and there, and all that becomes fairly straightforward. Well, what I just spoke, everything is exactly what they have sold OTel on as well. OTel, Open Telemetry, you guys are aware? Who hasn't heard OTel, or rather go the other way? Who has heard and who has used OTel in production? OTel in production? Grafana guys, timescale guys, lower down your hands. Anybody else? Okay, cool. Seriously, you have actually tried maintaining a pipeline of OTel in production and you haven't felt the pain of writing those receivers and those producers code? Much easier. But how is this different from Prometheus exporters? You know, you have a bunch of these Prometheus exporters out there, so many of them. How is this any different? This could exactly be the same. Well, here's a fundamental difference. Every time you have a new source of data, what do you do in a Prometheus exporter? You basically install a new binary, right? And you have no control over it. I only have 2 kidneys. If I keep downloading these Prometheus exporters, keep emitting the data, imagine the bill I have to pay. Yeah, this is just another scraper module in your file. What about the metrics? There's no way to choose. Do you ever know that, okay, how many of you use a Prometheus exporter with a CloudWatch compatible thing? Anybody uses CloudWatch metrics which are being scraped via Prometheus module? No? Okay, try that. And you would see a huge amount of bill next to you, sitting next to you. Building correlations. Any amount of metric correlation using those exporters is done as a post-processing thing. You know, you take that out, you pull that data in a Prometheus, you'll put that on a Grafana dashboard and you start correlating them. But over here, there's native support. And obviously, the last one, there's no logic manipulation possible. The same HCL versus any other benefit argument. Putting this all together, here's a simple workflow. All modern cloud components, you know, I'm just gonna summarize this. All modern cloud components are built on these complex layers. There's a binary, there is a load balancer, there's some database, there's some virtual machine, yada, yada, and they talk to each other all the time. And they all break all the time. The only way to stay on top of that is if you have observability baked in. And you're gonna keep running into this concept of selecting the metrics, the right ones that are important to you. And all of that can be simply done if observability was available as a declaration. openmetrics-exporter allows you to capture that. This was born at Last9. We are a company dedicated towards enabling you to ship reliable software in production. And I failed to introduce myself. I'm Piyush Verma. I'm the co-founder and CTO at Last9.io. If you're still interested, after this talk, you can go check the link. Yeah. Cool, open for questions.